In this video, I'm going to go through a few margin of error problems like the ones on your homework assignment. The first part of this problem says, is the sampling distribution at least roughly normal? In this problem, the statistic that's being calculated is the sample mean. So the sampling distribution is at least roughly normal if either the population is normal or the sample size is at least 30. One of those two things has to be true. In the diagram, we can see that the population isn't normal. The population is skewed, but the sample size is above 30. So the answer is yes. Just one of those two things has to be true for the answer to be yes. This part B says calculate the 80% margin of error. The statistic that's being calculated is a sample mean, so we need to use the margin of error formula for a sample mean. That formula is the confidence coefficient z times the standard error of a sample mean, which is the population standard deviation over the square root of the sample size. We need to plug three numbers into this formula. To get the confidence coefficient z, you have to go to a table. You have to go to a table and look up the confidence coefficient for your percentage. I already went to the table and it told me that the confidence coefficient for 80% is 1.28. So I'll plug that in right here. Next I need to plug in the population standard deviation, which is provided in the question. It's 4.7. Next I need to plug in the sample size, and it's provided in the question. It's 44. Now that I've plugged in all three numbers, I need to find the square root of 44. Square root of 44 is 6.63. Rounded to two decimal places. Now that I found the square root of 44, I'm going to divide 4.7 by 6.63. The answer is 0.71 to two decimal places. The third digit is an 8, which means the 0 rounds up. This rounds up to 0.71. That means we're going to be multiplying 1.28 by 0.71. That comes out to 0.91, rounded to two decimal places. So the 80% margin of error is 0.91. The next part of the problem says, what is the 80% margin of error telling you? It's telling us that there is an 80% chance or a 0.80 probability that the sample mean will fall within 0.91 of the population mean. I said that there's a 0.80 probability because we calculated the 80% margin of error. So this number just matches this number up here. This 0.91 is the 80% margin of error. It's the answer that we just calculated. And the next part of the problem says create a diagram. We know that the sampling distribution is at least roughly normal because we said that in part A. So let's make a diagram of a normal distribution. So this is the diagram of our sampling distribution. The population mean is at the center. In this problem, the population mean is 22. It says that up here. So I'm going to put 22 at the center. The population mean has a z-score of 0. Next, I'm going to mark off the boundaries of the middle area. And this middle area is the middle 80% of the sampling distribution. It's the middle 80% of the possible samples that could be selected. Next, I'm going to mark off the z-scores of the two boundary points. The z-score at the lower end of the middle 80% is negative 1.28, and the z-score at the upper end of the middle 80% is positive 0.28. This z-score is the same z-score that I plugged into the formula. It's just the confidence coefficient. So I got this 1.28 from up here. These two z-scores are just the confidence coefficient and the opposite of the confidence coefficient. Now let's find out what the two numbers are at these two boundary points. Not the z-scores, but the actual two numbers. We can do that by, well, before we do that, we have to label the margin of error at the bottom. We found out that the 80% margin of error is 0.91. So that means that this distance is 0.91. And this distance is also 0.91. Let's put 80% margin of error right here just to label that it's the 80% margin of error. So the 80% margin of error is just the distance from the population mean to the lower boundary and the upper boundary of the middle 80% of the sampling distribution. Now let's find the two numbers that I talked about. We need to take 22 and subtract by the margin of error. So 22 minus 0.91 equals 21.09. That's this number down here. So to get this number, I just subtracted 22 by 0.91. Now to get this number up here, I'm going to add 22 plus 0.91. So to get these numbers, I took the population mean and subtracted the margin of error. And I took the population mean and I added the margin of error. What this is showing is that there's a 0.80 probability the sample mean will fall between 21.09 and 22.91. That's because there's a 0.80 probability of the sample mean falling somewhere in the middle 80%. So up here, let's put 0.80 probability and draw an arrow just to label that the sample mean has a 0.80 probability of falling somewhere in this area between these two boundary points. This z-score is the confidence coefficient. When you calculate the 90% margin of error, it's 1.65. I got that from the table. I got it from the table of confidence coefficients. So we're just now we just need to plug in the standard deviation of the population, which is 4.7, and the sample size n, which is 12 in this question. So let's find the square root of 12. It's it's 3.46. Next, we're going to divide the fraction. We're going to divide 4.7 by 3.46. And we get 1.36. It rounds up because the third digit is an 8. So this fraction becomes 1.36. Now we just need to multiply 1.65 by 1.36. Comes out to 2.24. That's the 90% margin of error. When you calculate the margin of error of a sample mean, it's just 3 steps. You find the square root, you divide the fraction, and then you multiply. Part C says, what is the margin of error telling us? This should actually say 90%. And you change it so it matches. The 90% margin of error is telling us that there is a 90% chance or a 0.90 probability that the sample mean will fall within 2.24 of the population mean. I said 0.90 probability because I calculated the 90% margin of error. These two numbers just match each other. And 2.24 is the margin of error that I just calculated. Now I just need to create a diagram. We know that the sampling distribution is normal, so I'll make a normal distribution. So I'm creating a diagram of the sampling distribution. The population mean is at the center. In this question, the population mean is 22. It says that up here. 2 plus 2.24 is 24.24. So this is telling us that there's a 0.90 probability that the sample mean will fall between 19.76 and 22.24. We'll label that up here. There's a 0.90 probability that the sample mean will fall somewhere in this area in the middle 90% of the sampling distribution of possible samples. And that finishes this question. This question is a little bit different. In this question, we're saying that a certain population is 45% male and 55% female. A person is taking a random sample of 60 people from the population, recording their genders, and then calculating the proportion of the sample that's male. The first part of the problem says, is the sampling distribution at least roughly normal? We're going to have to use a different rule because we're dealing with a sample proportion instead of a sample mean. When a sample proportion is being calculated, the sampling distribution is at least roughly normal if n times p and n times 1 minus p are both at least 10. If both of these are 10 or larger, then the answer will be yes. So let's start with n times p. N is the sample size, which is 60. P is the population proportion. It's the proportion of males, not in the sample, but in the entire population. The proportion of males in the population is 0.45, because when you change this to a decimal, it's 0.45. So 60 times 0.45 is 27. That's 10 or larger, so this checks off. Now we have to do n times 1 minus p. 1 minus p is going to be 1 minus 0.45. That's 0.55. So let's multiply 60 times 0.55 and make sure that that's at least 10. It's 33. So this also checks off. Both of these came out to answers of 10 or larger. So the answer is yes. Next, let's calculate the 90% margin of error. The statistic that's being calculated is a population proportion. The statistic that's being calculated is a sample proportion. It's not a sample mean. So we're going to be using a different margin of error formula. we're going to be using the margin of error formula for a sample proportion. That formula is the confidence coefficient z times the standard error of a sample proportion, which is p times 1 minus p over n under a square root. So we're still multiplying the confidence coefficient by a standard error, but it's just a different standard error. It's the standard error of a sample proportion. So we need to plug everything into this formula. We're calculating the 90% margin of error, which means that this number is 1.65 again. This number just came from the table. P is our population proportion of males, which is 0.45. came out to 0.10. So this distance is 0.10. This distance is 0.10. Let's label that it's the 90% margin of error. .45 minus 0.10 is 0.35. That's this number down here. 0.45 plus 0.10 is 0.55. That goes right here. So there's a 0.90 probability, or a 90% chance, that the sample proportion will fall between 0.35 and 0.55. There's a 0.90 probability that the proportion of males in the sample will be somewhere between 0.35 and 0.55. So let's label that up here. There's a 0.90 probability that the proportion of males in the random sample will turn out to be a number somewhere between these two boundary points. And that finishes this question.